Hello students, welcome to the second lecture of the Microeconomic Theory course 2 post midterm break. In the previous class we were talking about various applications of the Nash equilibrium. In this class as well we will look at multiple interesting and important applications of the Nash equilibrium concept. And that sort of today's class will conclude this application, and from the Thursday's class we will start a new topic. Okay, so that's sort of is the plan of action. The first application that we'll be talking about today relates to oligopoly. So we are talking about applications of Nash equilibrium. And well, let's make it's the third example continuing from the previous class. So we'll be thinking about oligopoly as a market structure which we can analyze using game theoretic context. Okay, and the first thing I want to mention is that the Cournot model that we have talked about already before is actually a game theoretic model. So Cournot model is indeed a game theoretic model. Sorry, game theoretic model. Okay, and the reason is that here there are only two firms in Cournot, and they're choosing quantities. So you can think about quantities as strategies, and so this is a continuous strategy rather than discrete. And their payoff functions are given by the profit functions, right? Given the demand function. So you give a demand function, and that you plug that inside the profit equation, and that gives you the profit function as a function of Q1 and Q2, the quantities of the two firms, and then the profit functions of both firms become their respective payoff functions, right? And we have computed their best response functions, which is sort of the best or profit maximizing or payoff maximizing strategy, i.e. quantity, that a firm can choose for any given strategy or quantity chosen by the other firm, right? And then you the Cournot equilibrium, which is sort of the intersection of the best response function, gives you the mutual best response, which is exactly the definition of Nash equilibrium, right? So the Cournot equilibrium, is indeed the Nash equilibrium of the Cournot model. Okay, now remember that when we were talking about iterated elimination of dominated strategies, I had discussed how the same Cournot equilibrium can be thought of as the unique pair of strategies, the unique pair of strategies that survive iterated elimination of dominated strategies. Okay, so this Cournot equilibrium strategies or quantities were the unique rationalizable strategies. Unique rationalizable strategies. Okay, so the same Cournot equilibrium can be thought of as the one that survive iterated elimination as well as the Nash equilibrium. Okay, So you can think about Cournot equilibrium both in terms of Nash equilibrium of the Cournot game as well as the one that survives this iterated elimination. Okay. So so the Cournot equilibrium, you can think of this as the equilibrium strategies that's predicted by analysis of the context using game theory. Okay. So that's sort of I wanted to make this first point, that the Cournot model that we did it before knowing game theory, but I did that sequencing precisely because I thought that one doesn't have to know all the machineries of game theory to understand Cournot equilibrium. Like, it's a very intuitive way of understanding how firms will behave in that context. And now once we sort of know game theory, we can sort of go back to the Cournot model and see how Cournot model, the model that we built, actually indeed is a game theoretic model, and the equilibrium can be explained using various concepts of game theory, IEDS as well as Nash equilibrium. Okay. Today, within the oligopoly model, we're going to talk about another case. Okay. So the sort of second sub application within the oligopoly thing that we're going to do is called the Bertrand model. So that's the new thing we'll do today. It's a short model, but it's a model analogous to Cournot. So it is a two-firm. We'll think about a two-firm oligopoly or duopoly market. Okay. And instead of the firms choosing quantities to maximize their profits, in this case, firms choose prices. Okay. To compete instead of quantities. So what is the idea? The idea is that firm 1 and firm 2 choose prices P1 and P2 respectively. Okay. And they both produce a homogeneous good. So the assumption is that firms produce a homogeneous good. What does that mean? It means that, so it's like, the products are identical, right? So say both firms produce apples, and these apples don't have any brand value attached to the firm that is producing it. So it's like, both they produce identical apples. Okay. So the two outputs produced by the firm are identical products, and so they are perfect substitutes in the minds of the of the consumers, in the preference of the consumers. Okay. So these are not like, say, Pepsi and Coca-Cola, because even though technically they could be identical, but people have brand values attached to these various products, so they are not perfectly homogeneous. Okay. So but we are not thinking about such cases. We are thinking about cases where firms produce stuff that are perfectly substitutable, okay, in the preference of the consumers. So firms output are perfect substitutes. Okay. So that's what it means to be a homogeneous good. So firms choose P1 and P2 respectively. So firm 1 choose P1 firm 2 chooses P2, and the profit of firm 1 is given by P1 Q1 minus C naught of Q1, where C naught is the marginal cost of production and pi 2 is P2 Q2 minus C naught Q2. So they both firms have identical marginal cost. Okay. Now, what is the idea? The idea is that they choose prices, and there is some latent demand function. So let's assume that total demand for a product is A minus B minimum of P1 P2. Okay, what is this idea? What is this demand? So basically the idea is the following. The idea is that consumers look at the two prices. Okay, whichever is the lower price, the all the consumers buy from that firm's buy from that firm. Okay, why is that? That's because of this homogeneous good assumption. Okay, because the good is homogeneous, consumers don't have any specific attachment to the output produced by any specific firm. So whichever firm offers a lower price, all the consumers flock there. Okay. Now you may think that this model is unrealistic, in the sense that even if they're sort of competing over prices, people have brand values attached, and so in most cases probably this doesn't make sense. And there are models where the good is not homogeneous. So those models work kind of like Cournot, except that instead of quantities, people fight over prices, and it's not the case that if my price is below your price, everybody will come to me, but it will sort of come to me gradually. So the lower the price that I set, more consumers flock to me from the other firm, but it's not a 0-1 thing. But here we're modeling the 0-1 thing. One way, sort of one application of Bartra model is think about cases where say a big industrial is acquiring land from some farmers to set up a factory. So see, this land acquisition case, the particular quality of the land per se is not of interest. What is interest is they have the industrialist gets a contiguous set of land. He purchases land one next to the other, like one block of land altogether. But there, as long as the land parcels are contiguous, specific, the consumer. So here the consumer is this industrialist who's buying from all these producers, quote unquote producers, who are these land sellers. And there, all the industrialist cares about is the price quoted by these land sellers. Okay, so whichever farmers quote lower price, the industrialist starts buying parcels there. Okay, so there, so as long as the industrialist has options to buy from one set of farmers versus the others, you can think of that scenario as one mimicking the Bartra model, where the good, in this case land parcels, are in some sense homogeneous, meaning that the specific quality of the land is not of interest for the industrialist. Okay, so in that context, you can think maybe Bartra model is the model that is more suitable. So in any model or in any context where brand value is not that important, people care a lot about price than about brands, there you can think Bartra model would be more applicable. Okay, so just to repeat, the firms simultaneously quotes price, and all the buyers, they see which price is the minimum. So that's why I've written minimum, just to highlight. That's why I've written minimum. Oops, sorry. That's how written, minimum P1, P2. So whichever is the minimum price, the demand goes there, and the demand is given by Q equals A minus B times price. Okay. So in that, and Q1 is, so if P1, so let me just write, if P1 is less than, excuse me, if P1 is less than P2, firm 1 gets all the demand, okay, and firm 2 gets zero demand. If P2 is bigger than P1, of course the other thing happens, Q1 becomes 0 and Q2 becomes the total demand. And if prices are identical, the firms they get half of the market each. Okay, so that's the idea. And so as you can see, the firms will have incentive to undercut each other. So every price that is above, so what will happen, if you can imagine, every price that the firm 1 quotes which is above C naught, so for any price above C naught, firm 2 will quote P2 which is just below P1 and get the entire market. Okay, and same for the other firm. So if P2 is above C naught, firm 1 will undercut and just charge something below, because any price above P2, firm 1 gets 0, or any P2 above P1, the firm 2 gets 0. So everybody wants to undercut the other firm and charge a little bit lower. Okay, and this will continue as long as the prices are above C naught. That can't be. So I mean, I'm saying sort of how the thought process of the firms. So the point being that in equilibrium, prices quoted by the firms cannot be above C naught, right? That cannot be an equilibrium outcome, that the firms quote prices which are above C naught, because any price that is above C naught charged by any firm, the best response of the opponent firm is to charge right below that price, so that it gets the entire market, and that sort of maximizes the payoff of the opponent firm. Okay, so in equilibrium, prices cannot be above C naught. So the only equilibrium here is that they'll keep undercutting, and the equilibrium will be given by P1 star equal to P2 star equal to C naught. Okay, so they'll keep undercutting each other until they hit the marginal cost. If they hit the marginal cost, they can't go below. If they charge below marginal cost, they'll run loss. So it's better to earn zero profit than earn loss. Okay, so this is the unique Nash equilibrium of the game. Okay, think through it, why this is the case. So consider any prices P1, P2 such that any of P1, P2 is above C naught. That cannot be an equilibrium. Okay, just think through that, and you can easily see why that would be the case, because again of the undercutting incentive. Okay, now this is assuming that both firms have the same C naught, the same marginal cost. If two firms have different marginal costs, say C1 and C2, such that C1 is bigger than C2, then what will happen is that in equilibrium, they'll keep undercutting until they hit C1, right? So now you hit C1, now there is no undercutting incentive, because So both firms, so here firm 1 gets 0 profit at P1 equals to C1. At P2 equals to C1, firm 2 gets positive profit, right? Because firm two's profit is P2 times Q2 times C2 times Q2, and P2 is C1, so it's C1 minus C2 times Q2, so that's positive. Okay. Now the idea is that at this price, consumers are indifferent between going to firm 1 and firm 2. We assume that, let's say all consumers go to firm 2, because otherwise if we assume that both firms get half of the market at P1 star equal to P2 star equal to C1, then firm 2 has an incentive to undercut a little bit more and get the entire market. But then it's not clear what would be the best response. So because we do not have a unique we do not have a best response for firm 2, right? Because for any P2 below P1 star, you can always increase the price P2 by a tiny margin, which will be still below P1 star, and it will still be the case that you will the firm 2 will get all the market. So the in because of this continuous strategy assumption, we do not get a best response for firm 2. So that's why we are saying that the Nash equilibrium will be given by this, with the assumption being that all consumers go to firm 2, and it doesn't matter, because in any case firm 1 profit is 0 in under both circumstances. So firm 1 especially, it will not affect firm 1's payoff function, and it will ensure that firm 2 indeed has a best response to charge P2 star equal to C1 when P1 star equal to C1. Okay, so that ensures that this P1 star equal to P2 star is a Nash equilibrium. So basically the firm which has a lower marginal cost earns a positive profit, and the firm and gets the entire market, and the other firm, in this case firm 1, doesn't get any share of the market. And here firm 1 doesn't have incentive to undercut below P2, because the moment it goes below P2 star, it goes below its own marginal cost, so it goes into the loss region, right? So firm 1 doesn't have any incentive. So this is sort of a model where you see that the moment you have two firms competing over prices and producing a homogeneous good, you get this outcome of both firms charging their marginal cost. In this case, when both firms, so in this example, when both firms have when both firms have identical marginal costs. This is also the perfect competition outcome, because C naught is also the average cost of production. So the long run perfect competition equilibrium is given by price equals the average cost. So here you see that even with two firms in oligopoly, you can have the perfect competition, unlike in the Cournot model, provided that the firms are producing homogeneous good, which was the assumption in perfect competition as well, but they are competing over prices, right? So price competition is a much fiercer form of competition than quantity competition. So in the quantity competition, you have Cournot, which is this case. You have the Cournot. And in the price competition, you have the Bertrand, which is this case. So this is the Bertrand equilibrium. So Bertrand's point was that instead of quantity, if you think about firms competing over prices, you actually, even with two firms, you get efficiency. Okay. But of course, if brand values come in, that will not be the case. It will sort of be something like a Cournot. Okay. So that's the first application. We go to the next video to talk about the second one.